Okay, the next question is question 5. There's our diagram here on the right hand side. We see we have line AB, we have line BC, we have D there as well. Point A, we have the coordinates E and 1. Point B, we have the coordinates 1 and -2. We have the coordinates of point C, 3 and 3. And D, we do not have the coordinate there, but we can see that that is the x-intercept as given there. We also have an angle alpha at D. So 5.1.1, determine the equation of line BC. Okay, whenever they want the equation of a straight line, in this case BC, you start with the standard form of the straight line, which is y is equal to mx plus c. We start by finding m, which is the gradient of the line. If you have 2 points on the line, you go straight to using the gradient formula from your data sheet, which is m is equal to y2 minus y1 all over x2 minus x1. Okay, you write down your point B and C. Coordinates there label as x1, y1, x2, y2. Substitute that directly into your gradient formula as follows. That will become 3 minus -2 over 3 minus 1. On your calculator, you'll get an answer of 5 over 2 as your gradient. Substitute your gradient answer into the y is equal to mx plus c formula, and you'll end up with y is equal to 5 over 2x plus c. To solve for c now, you need to substitute any point that lies on line BC. So we can either substitute point B or point C. I have chosen here to substitute point B, 1 and -2. So wherever I see x, I will put 1, and wherever I see y, I will put -2. So my equation now becomes -2 is equal to 5 over 2 into 1 plus c. If I solve for c here, I'll get c equals to -9 over 2. Substitute that into my equation, and I'll finally have y is equal to 5 over 2x minus 9 over 2 as my equation of line BC. 5.1.2 now, hence calculate the coordinates of D. As we said earlier, if you look at the positioning of D on the diagram, we can see that D is on the x-axis, so that would make D the x-intercept of line BC. So for the x-intercept, the rule is make y is equal to 0. We have the equation of BC already, so in that equation, all we have to do is make y equal to 0 and solve for x. So if we make y 0, we'll end up with the equation 0 is equal to 5 over 2x minus 9 over 2. We need to solve for x here, so we can leave the x term where it is. We'll take the constant term over. So -9 over 2 will become +9 over 2 on the left hand side. So 9 over 2 is equal to 5 over 2x. Divide both sides by 5 over 2 to get x on its own. We'll end up with 9 over 5 is equal to x. So our coordinates of D there will be 9 over 5 and 0, as it is the x-intercept of line BC. 5.2 now, calculate the value of E if AB is equal to BC. Okay, if you look at where E lies, E is the x-coordinate of point A, as we can see on the diagram. They gave us here that AB is equal to BC. What this means is, it means that the length of AB is equal to the length of BC, or the distance of AB is equal to the distance of BC. Now the word distance should take your mind to your data sheet, where you have your distance formula that you can use. So in this case, we can't directly find the value of E because we don't have the distance of AB. We don't have anything else there to solve for that x-coordinate of A. So we'll use the distance formula, but we will use the distance of line BC first to get to point A. So if we find the distance of line BC, you can label your points B and C, x1, y1, and x2, y2. Use the distance formula, and you'll end up with the square root of 3 minus -2 all squared plus 3 minus 1 all squared. And you'll get the distance of BC there to be the square root of 29. But we know that the distance of BC is the same as the distance of AB. So if we're working out the distance formula of AB now, we can label the coordinates A and B as x1, y1, x2, y2, and put that into our distance formula. But that distance formula can be equal now to the square root of 29, which is the same distance as BC. So we'll end up with an equation that's the square root of 29 is equal to the square root of negative 2 minus 1 all squared plus 1 minus e all squared. We can cancel our square roots off, so we'll end up with 29 is equal to 9 plus 1 minus e all squared. We need to isolate our e term, so we'll leave the bracket where it is, and we'll take our constant of 9 over. That will become negative 9. So 29 minus 9 will give me 20 on the left hand side. 20 will equal to 1 minus e all squared. If I want to get to the e on the inside, I need to get rid of the square. So I will square root both sides of that equation, and I'll end up with the plus minus the square root of 20 is equal to 1 minus e. So for e, I can take e over, so e will equal to 1 minus the plus minus the square root of 20. I can put that in on my calculator and I can get my value of e easily, remembering that e is on the negative side of the x-axis. 5.3. Determine the value of alpha. If we look at our diagram, alpha is an angle that lies on the x-axis. It lies between the x-axis and line BC. So if we want to solve for alpha, which is the angle there, we're going to use the formula m is equal to tan theta. You'll find that formula on your data sheet as well. Now the m there stands for the gradient. It stands for the gradient of the line that the angle is next to, close to the x-axis. So BC is our line that we choose. So we need the gradient of BC. We did work out the gradient of BC earlier, and we found that that gradient was 5 over 2. So substitute that into this m equals tan alpha formula, and we need to solve for alpha here. So 5 over 2 is equal to tan alpha. Alpha then will equal to tan inverse of 5 over 2. Put that on your calculator, so shift tan 5 over 2, and you'll end up with alpha is equal to 68,2 degrees.